So this is going to be an experiment doing a voiceover because I have the video is very sped up and I haven't really had a chance to edit it properly, and I don't have any proper explanation anyways. So at this point I'm removing the one shot, or moving the one shot and removing the spray mist system. The spray mist system didn't work. It was slightly damaged, and actually in the process of tearing it down, as you can see here in a minute, it actually is full of terrifying moldy old spray mist coolant stuff, whatever the fluid is, like with chunks floating in it, and was kind of horrifying. I also went ahead and removed most of the pneumatics built in, simply because one of them, the speed control thing, which basically sped it up or slowed it down, is not attached at all anymore. What with the new VFD, and the other one, the brake is, well, the brake would actually be kind of nice, but that would mean I need a compressed air source, which I don't currently have. So I've just decided to do without it and just manually kind of pull the brake lever, which works fine. So that you can see the wires dangling. At this point, we were looking at putting new encoders on the system because these are sine cosine encoders. They're pretty fiddly, but it's like 150 lines per revolution, I believe. But then it's an analog system, so you can do linear or they do interpolation. So you can get, I think, 2,500 counts per revolution or something like that. This is a Mesa 6i25 7i77 Linux CNC, basically like anything I/O board. This is obviously a little 12-volt power supply. I'm using one of those Pico PSU things, which you feed 12 volts and it DC to DCs down to everything else. So I just put a little brick in the computer housing. I sold the old controller to some guy on eBay for a decent amount of money. I think I got like $700 for it, because if you have files for them, you kind of need them, because there's nothing else that runs it. It runs Heidenhain conversational NC programs, and basically nothing generates them anymore. I don't think Heidenhain even supports the language to any significant extent anymore. So sorry, what I was doing there is I was fiddling with the servos in the system are they're constant velocity. They're velocity servos, so you put in a voltage and you get a velocity, rather than most servos where you put in a voltage and you get a torque, which means that the control loop for the Linux CNC will actually be a lot easier to tune. But again, there's actually a tachometer on there, so they're more complex, but fortunately they're all set up, so I don't care. At this point, I decided to, or actually Isha and I kind of decided to just rip out a lot of the existing safety interlock stuff. Basically, the system has a whole pile of relay logic, because the Heidenhain controller didn't have a lot of facilities for like the interlocks for changing this, disallowing speed changing when the system was running, and a lot of other similar stuff like that. So they actually implemented a bunch of logic outside of the Heidenhain controller using a whole pile of relays. I actually basically wound up drawing a schematic for the entire system, but it just was so convoluted and obnoxious, and half of it was running 120 volts, and it was just annoying. So I wound up basically we just tore it all out, and at this point I guess it has probably a few fewer safeties, but that hasn't really been a problem. I still have, basically the e-stop buttons are still active, and the e-stop buttons work, and the limit switch, the end of limits work, and other than that, what else do you really need? I mean, I'm trying to remember what a lot of it was. A lot of it was related to interlocks for how you had the speed control system, again, because it basically operated by cranking the knob that you'd normally turn on a bridge port to change the speed. It had to be certain that the spindle was on and powered. So there's a lot of interaction between the spindle and some of the solenoids, and how the controller then talked to them to some extent. Let's see what else was in there. There was just a lot of like additional complexity that I don't really understand why was there. But in any event, removing it and then just kind of going to just a generally simpler thing, because I have a lot more GPIO. The Linux CNC stuff has, I think, 48 digital inputs and 16 digital outputs, whereas the Heidenhain controller had 8 I/O. So it was much more limited, and also it was much less configurable with regard to how, kind of an interface with the system. So they had to kind of bootstrap a lot of logic around it just by doing horrible things with, relays. Or I guess, not horrible. It was cool. It just was pointless at this point. So at this point, I'm kind of doing the basic wiring. Those big heavy gray cables are the analog control voltage inputs for the servo system. It's actually, the servo system inputs are actually differential. which is kind of cool, but they're effectively routed as a differential pair all the way up to the controller, where they're then one of the ends of the pair is grounded, and effectively it's single-ended at that end. So I think this is the first time I got the system to move. I think, yeah, you can. I think you can actually see down there, or you could have seen down there on the right hand side, there was cables dangling out of the encoder. We replaced all the encoders with modern US Digital branded quadrature encoders. I think they're 2,500 cycles per revolution, which basically means it's 10,000 edges per revolution. And the math worked out to us resolving, I think, around 10 encoder counts per tenth. So that's, way more resolution than the system can ever reasonably actually move to, but it should allow it to servo to hopefully a thousandth or so. At this point, we had a lot of issues. The encoders on the X and Y stage worked right out of the box, but the encoder on the Z stage, the disc on it, actually the encoder head was not quite properly aligned because we aligned them by hand. So what happened is, for half of the revolution it worked, and for the other half of the revolution it lost tracking, and that led to basically the Z servo kind of going run, 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 as in it would accelerate very hard for basically half of the rotation, and then slow down, and then properly close the loop for the other half of the rotation. So moving it was problematic. Well, it wasn't problematic, it didn't move properly. So that was very confusing for a while, until I wound up pulling the belt off and telling Linux CNC to output a constant control voltage into the servo, and then looking at the read back velocity from the encoder, which just dropped out for fully half of each revolution. And it's like, oh, it must be misaligned. Loosen the screws, shove it a little bit, and it started working fine. Oh, well, that must be the problem. At this point, I'm trying to make the wiring a little nicer. I went and took the little carrier plate that the breakout board is mounted on, and mounted some little zip tie, screw down zip tie retention thing, so that I can strain relieve the cables. And now I'm making a very impromptu chip guard with a bit of shop rag. I think this is the first thing I ever machined, well, at least with this CNC, and I'm just validating tool paths on a piece of 2x4 because it was there. So that was the homing routine that has to travel over to one corner to home the system. I was filing things out the door, which is why I was standing there. This was probably the worst possible thing to try for your first machining operation, but that's a sheet of I think it's 1/4 inch stainless, which is, I don't know. Basically, I've been needing to make collet wrenches, so because I don't have collet wrenches for either the small collet or the spindle nose. You can see I just put some channel locks on there because I'm a horrible person. So this is just, is the tool path doing what I want? Blah, 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 kind of just letting it trace its thing to make sure that it's behaving the way I expect it is. It's cool to watch. It's not, excuse me. Obviously, it's sped up, I think, 64 times. So this was just me looking in one of the encoders. So you can see the little sine cosine windows. I forgot I put this clip in here. I actually thought I didn't. And that was just a random project from work and looking inside an ARM programmer. So that's actually the first time I've made... Well, that's not the first time I've made metal chips, but it's the first time I've made metal chips with Linux CNC. So it seems to cut stainless without too much trouble. One of the problems I did have is that my spindle RPM is a little low here. So I've subsequently swapped the pulleys in the head to give me a much higher, spindle RPM. So I just rigged up a blower system with my shop vac, which is what that was. So it's cutting pretty nicely. I don't have any idea what I'm doing with regard to a lot of this stuff, so whether or not I'm doing it right is kind of another matter. But it certainly, the cutter seemed to be in fine shape when I stopped it and looked at it. So at least for that portion, it was fine. Slightly foreshadowing there, you'll see in a little bit. Another thing worth note is at this point, I'm one of the things I've spent actually the last month and a half doing is learning, how to properly generate cam files, because the tools I've worked with, I don't really have access to anymore. I don't really have SolidWorks at this point, though. I wish I did. I've subsequently moved on to Autodesk Fusion 360, which is free and not as nice. And I realized right there that was going to be a problem, that the spindle nose or the lock nut was going to hit that. So we'll see something happen right here. Ping! Uh-oh. So what happened there is the metal bowed up because I was clamping it too far on the edges. And you saw how the end mill broke. And what happened is actually it broke inside the collet and fucked up the inside of the collet. So I actually wound up breaking the collet trying to get it out of the collet nut, because it basically kind of smooshed the metal around. So it was only visible very quickly in passing there, but I wound up buying 4 collets on eBay for $6 a pop, and was not too unhappy with that. That's me very inadequately attempting to tram in a piece of aluminium, but it doesn't really matter. So at this point I had more or less decided, okay, trying to do the first thing I shouldn't try to machine out of stainless is probably dumb. So I bought some half-inch aluminium bar and have been trying that. The problem you'll see here, or I think I made, I think, 4 or 5 of these things, because the first 3, for some reason, the cam tool chain I was using at that point was not compensating properly for the tool diameter. So it was effectively, all the walls were cut 0.2 or 0.125 inches too thin, which basically means that it didn't really fit. The other problem I had for this particular portion, at least, was that my safe depth, or my safe height, was, I think, 1/4 of an inch above the surface, which is why it spends so long plunging through air. I just checked the tips of the tool right there. So you can see it spends a long time. One cool thing you can see here is helical plunges, yeah, baby, which was pretty awesome. I just figured, hey, there's a checkbox, and the machine should be able to follow 3D toolpaths. Let's turn it on. And they're awesome. So, this actually came out pretty nicely with the... It machined it, the machined result of this was great, with the exception of the fact that it was dimensionally wrong. And only for the outline, too, which is weird. At this point, I have my shop vac hooked up, functioning as a blower to clear chips out of the way, which is why there's no chips there. You can see they're actually shooting out the door to my shed and made a god-awful mess in the yard. Oops. I've subsequently fixed that with a much more effective chip cooling mechanism, namely flood cooling, which you'll see momentarily. But yeah, it just goes on and on. I just enjoy watching it machine. You can see I started going, maybe I should put oil. And then the oil all blows away, so who knows how much it helps. I should probably try at some point attaching... So I think I did a constant step down toolpath on this, so it's basically continually ramping down. So I just turned the vacuum off, and you can see how much of a mess it's making. I don't know what I was doing. I just hooked the vacuum up properly. So now it's the fallout with the vacuum toolpath clearing. And at this point I had to move the clamps because the part was starting to break loose. So it basically had broken loose at that point, and it sure looked nice, but it was too big in diameter, so it effectively didn't grip the spindleness. At that point I got sick of that shitty, well, not shitty, the obnoxious 1/4 inch collet holder, and bought a bunch of rigid tool holders on eBay for way too much money. And then also got sick of the wet dry vac, so I have had some perforated stainless sheet, which, as you can see there. So I got irritable enough to finally cut it up and drill holes in it and mount it properly on the table drains, which you can see one of the table drains right there to the left-hand side. And what I'm basically doing now is, there's the other one. I had to chase out the holes because they had God knows how many years of crud in them. So effectively those little drains just, it filters out at least the bigger chips. So this was an experiment. That's a giant chunk of polypropylene with a huge, ridiculous end mill. This is a different project. That's a fan cowling for my cable modem, which keeps overheating. It's polypropylene because it was, I think, $13 for that giant brick. So, you're fortunate, actually, that you can't hear the audio here, because this thing with that enormous stick out you can see there made god-awful, horrible buzzing noises while it was cutting. Also, I'm pretty sure my feed was actually not aggressive enough. I'm still, kind of trying to figure out what the hell I'm doing. So, it actually, later on, you'll see it in a minute, I did some much more aggressive machining with a slightly larger tool, and it sounded much better and made much nicer chips. Though they were big enough that they did manage to clog up my shop vac. The nice thing about machining plastic is the chips float, which means that assuming you have flood cooling, the cut point is actually self-clearing. Basically, at this point, it makes fluffy little clouds. Bob Ross would be happy. So yeah, it's just, this is the I think the Autodesk Fusion adaptive clearing thing. So it kind of did some weird. I don't really understand exactly the logic of why it behaves the way it does. The other problem is when it reaches all the way to the ends, the way the two jets are aligned. Whenever they start spraying directly on the plastic rather than into the cavity, they spray coolant everywhere. Basically, it makes a very effective sprinkler, if nothing else. So that's what the big blocks of aluminium are there for, is to try and keep the splashes at least contained to the table, because the table drains properly. You can see I probably also maybe should have considered the anti-foaming coolant. There's a coolant, you can buy the no foam coolant variety and then the normal type, and it foams up a little bit. So the last step here was, because it's got some slanted surface, was to just do linear paths back and forth to try and smooth out the contour. So that's what it's doing right now. So I actually did just a zigzag path back and forth in actually each direction. You can see it hit one of the log line coolant hoses hit something there, and it kind of bent into the seam. So now we're going the other way. God, I wish the machine was this fast in real life. Remember, it's running like 32 or 64 times faster than in reality, so I was being very conservative. Great big hole in there. So then this is my ultra high performance water cooled wood saw. Actually, the real problem I had with that is that the saw was too long and it would track coolant over the edges. So I bought that vise subsequently, which you'll probably see a review of in the near future. And at this point, I'm just doing like a surface cleanup, just cleaning up the edges. You can see my shop vac, the hose just totally clogged up, and I think I unclogged it. I gave up eventually. So now I'm machining the other half now that it's kind of flipped over, playing with the edge finder, which actually works surprisingly well. So that's I think it's a 5/8 inch tool. But yeah, you can see it basically just sprayed chips everywhere. I think this is, I'm running the cut a lot faster at this point because the tool was much more rigid, and I had better work holding. So I'm just like, fuck it, turn it up to, well, actually turn it up to what it's supposed to be. And then just trying to do some deburring.